Welcome back, students. This is Mr. Campbell here, entering our second to last week of e-learning. Hope you guys are excited for summer break. But before we can get excited about summer break, keep in mind we've got to finish our e-learning. We've got to finish our classwork, finish as strong as possible with our work so we get the highest grade possible. And with that being said, I've got some news for you guys that I think you will be pretty happy about. This will actually, even though it's the second to last week of e-learning, this will actually be the last week of new class content. I've made a post about this on Edsby. This includes just 4 video lessons. I've kind of delayed our most recent quiz to today, Monday, so I'm going to post that in a little shortly here. We'll just have 2 quizzes, 4 videos, and I believe 1 assignment and 1 notebook check. So that'll be the end of the semester, or the quarter, I should say, for our e-learning. So because the last week, the week after that, which would be semester exam week, right? That is actually going to be used as a makeup work week. So stay ahead of your work, get caught up on all of it, and submit it, and you will have all those completed this week. You will be all done with Earth Space Science for the school year. So super excited, guys. Hopefully I'll get all those up as soon as possible, especially the quiz and the notebook check today for sure. And all of those will be due the middle of next week. I'm going to say like Tuesday, Wednesday, but if you get it done this week, so you can be done with it, right? That's kind of the idea. Okay, look here, guys. Go blue. Number 1, what wave types have the A highest energy and B lowest energy? 2, what colors have the A highest energy and B lowest energy? And 3, blank nebulae form from massive stars, while blank nebulae form from lower mass, less massive mass stars. What are going to be the best answers? Take a moment to think about it. Look back. Again, that diagram you guys drew, I think on page 14 or 13 or 15, I can't remember which one. But if you look back here, let's move on to our answers, guys. And the answers are going to be gamma rays have the highest energy, microwaves have the lowest energy, 2, violet has the highest energy, and red has the lowest energy. Remember Roy G. Biv. And then 3, stellar nebulae come from massive stars. Planetary are from our smaller stars. Okay, so just a roundup of some of the answers, some of the topics we've discussed in previous lessons from last week. All right, go ahead and update the pages 18 through 20 star classification. We're gonna basically just finish Unit 8 for the year, guys, with our next 3 video lessons. We have a Unit 9, but we won't have time to get to that. So I'm just gonna give you guys, like I said, a vocab assignment for that, and that'll be what we do for Unit 9, given the unforeseen circumstances of the situation with what's going on, right? Okay, so let's go and do our first practice question. What is most likely the final phase of a low mass star? Is it A, red dwarf star, B, black hole, C, neutron star, or D, white dwarf? So those smallest of stars, those low mass stars, they last quite a long time. Again, the smaller star, the longer it lives compared to a larger star. What's the most likely outcome of its last phase of life? It's going to be, guys, the white dwarf. It's going to fizzle out on the outside, form a smaller nebula, and then what's going to be left over is that core. I'm going to call that a white dwarf. All right, so go to page 19. Today we're going to discuss how scientists, how astronomers classify stars. So let's check that out. Okay, well, page 19, star classification. Okay, we're going to look at 3 things here. The 3 things we're going to look at, again, make sure to write this down, guys, for notebook checks, for quizzes coming. We still have 2 quizzes. We'll make sure you have those answers in those notebooks, right? We have heat, temperature, and luminosity. You guys know what heat is and temperature is, right? Amount of energy, yada, yada. But what's luminosity as well? Let's get to that. Well, heat, okay? Energy that flows from a region of higher to lower, right? So when energy, it's always going to want to flow from the higher area to the lower area, higher energy to lower energy, right? If it's more condensed, it's going to want space and it's going to want to be able to relax. Again, energy always wants to relax, so it's going to high area to low. Temperature is the average speed of particles in a substance. So again, heat and temperature, oh, they're the same thing, right, Mr. Campbell? They're similar. they're related, but they're not. If you look at their true definitions, what are the differences, right? So again, the average speed of particles in a substance. Temperature is the speed of it. Heat is just the flow of it, essentially. But now, those are ways we look at we compare stars. But let's take a look at this last term, super important on page 19. And again, as I always say, pause the video when you need to. If you need more time to write these ideas, fine with me, no problem at all. Okay, luminosity. Okay, luminosity, which some of you guys may already know, is the brightness of a star, how much energy it's putting out, right? The brightness of a star. Okay, again, we're going to measure this by luminosity. So one luminosity is equal to the sun. Okay, we compare stars to our own star, the sun. So 1L, one luminosity, is that's the same brightness of the sun. Okay, so let's see. I'm going to actually add something here. Let me go. I just want to make sure I cover all the important points here. Hopefully, it doesn't freeze on me, as it will tend to do at times. If when you're recording videos, the computer gets really has to really make sure everything's all set up the right way so it doesn't exit. But let's go exit the application. All right. So yes, star brightness, energy output of a star compared to the sun. 1 lumen equal to the sun. 10 lumen is 10 times the output of the sun. So every L with a single digit is going to be 1 more greater than the sun. And it's affected by a star's temperature as well as the star's size. So again, scientists aren't just looking at the stars from afar. We're looking at their brightness. We're looking at their size. I mean, they're measuring things as they look at them, right? Okay, so go ahead and write these 2 video questions down on page 18, as you see here. What characteristics are analyzed to classify stars? Might have mentioned a few of them earlier. And 2, what star color is the hottest? And B, coolest. Okay, super important to know. Got to know the temperature versus coloration of the stars, right? Let's go and check out. I posted this on Edsby for you guys already. Oh, you're going to draw that here in a little bit. But let's go ahead and check out a little snippet of what that'll be about. Oh, and I think it's showing right away right here, right? Okay. Again, we're going to measure star temperature in K, which is known as kelvins.
And B stars are blue, and cooler objects like K and M stars are red.
Oh, it gave
also,
it away.
Hotter stars tend to be larger and burn brighter, with the additional heat resulting from the fact that so much more fuel is being burned. All of this data regarding temperature and luminosity, as well as indirect information on mass and radius, can be represented on something called a Hertzsprung-Russell diagram.
That is exactly what we are going to talk about right now, the Hertzsprung-Russell diagram. If you didn't catch it, okay, again, measuring in kelvins temperature, the hottest stars are going to be, according to the diagram, blue, and the coolest stars are actually red. Contrary to what we learned about here on Earth with fire and a little bit and this and that and what's hot, what's cold. It's actually blue is the hottest, like a blue flame is the hottest part of a little match flame, whereas the red is the coldest, believe it or not. Pretty interesting, surprising stuff to many. Again, don't miss that when you see that on the quiz coming up. But let's go back here and get to that diagram. So what I want you guys to do, you may, and this is on page 19, probably half the page. You need the whole page. Maybe use page 19B. I'm just gonna put my screen down. You know what? I'm still in the way. There I am. All right. So on the y-axis we have luminosity, how bright it is. On the bottom, the x-axis, we have temperature. Okay. So what I want you guys to do is just sketch this out in your notebooks. I had a note sheet to give you in class where you would color and label the different parts of this chart, because you would have seen this chart on your test, except it wouldn't have had any labels on it. So look to see this again maybe on a quiz coming up. But as we can see here again, the hottest stars are blue. In the middle we have white stars and yellow stars, and the coldest stars are red. Pretty simple. Now, what trend do you see in regards to luminosity? What kind of stars are the brightest stars? It's going to be the larger stars, the giants, the blue giants, the red supergiants. And by the way, also make sure you label that the sun right here, right there, right in the middle, happy medium, okay? We're a less massive star, and we have a yellow star. Now, eventually, that star is going to get a little larger. It's going to turn a little more red. And that's when it starts producing iron. That's when the star begins to die. Okay, it takes a long time. Nothing to worry about. We got a couple more billion years till we need to worry about that. So that kind of goes over star measurement in regards to brightness and temperature. So make sure you guys copy that down to page 19. All right, and two little notes I want you to write about it. Hertzsprung, and it's called the Hertzsprung-Russell diagram. Could be another thing you see. It's a scatter graph of stars showing the relationship between the star's luminosity versus Kelvin. I might ask a question where, like, I say, what two factors help scientists measure stars? You got to know. Temperature, luminosity. Used to predict a star's stage of life, right? So a star won't always stay the same form. Our star is going to eventually get larger. The sun's eventually going to turn red, according to our scientists, right? So things to think about. Let's go ahead and take a look at another little clip here, kind of further explaining that chart for us. Hertzsprung-Russell diagram.
Or the HR diagram for short.
HR diagram, also known, yep.
It's a rather important diagram. In many ways, what the periodic table is to chemistry, the HR diagram is to astronomy. As a chemist myself, I like to call it the periodic table of astronomy. Of course, don't memorize this thing. Rather, let's learn how to read it.
Okay. So again, not looking for YouTube to get on me about showing too much of other people's videos, but very good, kind of breaks down the graph. Again, you're going to see this twice. Check it out. But again, it's all about luminosity, brightness in the y-axis, and temperature on the x-axis, right? Blue's the hottest, red's the coldest. The larger the star, the brighter it is. You guys get the idea. All right, let's finish up for the day. Pretty simple, straightforward stuff, right? Last question. What type of star is our sun? Little typo there. Oops, I'll fix that. What type of star is our sun? Oh my goodness, guys. I totally forgot to fix the question. Let me fix this. Okay. The question is, what type of star is our sun? There we go. Oh, I gave it away. But you guys hopefully already knew it. It is B, main sequence. Our star is not a dwarf star. It's not a massive star. It's not a neutron star. Okay. The best answer would have been main sequence B. So if you got to know what type of star our sun is, it is the main sequence. All right, guys. So I'm going to go ahead and work on the notebook check post. After I get this video posted, I'm going to get the quiz questions up, hopefully within the next hour or so. Again, if you have any questions, let me know. I've got to get back to a few messages from people from yesterday. And like I said, all quizzes are open, all old assignments. You can still get partial credit on them. Okay, I'm being flexible with grading and fair at the same time. So take advantage of that. We have 2 weeks left. Only one more week of new content. Last week is makeup work. Mr. Campbell, signing out.